Hi everybody. Today for math, you're going to look at multiplication with regrouping, also called the regular algorithm, which is better known as my parents' way of doing it. Let's take a look at this problem. A thoroughbred racehorse can run at speeds of up to 60 feet per second. During practice, Celia's horse runs at a speed of 36 feet per second. How far does her horse run in 3 seconds? The question is, how far does her horse run in 3 seconds? And when I look in the problem, I see that Celia's horse runs specifically at 36 feet per second. The fact that they can run up to 60 feet per second is extra information that I don't need for this problem. If Celia's horse runs 36 feet per second for 3 seconds, that means she did 36, another 36, and another 36. So I'm going to find the answer to this problem by doing 36 times 3. To solve 36 times 3, using the regular algorithm, I still need to remember in my mind that 36 is in fact 3 tens and 6 ones. And step 1 in the regular algorithm is to multiply by the ones. I'm going to multiply 3 times my 6 ones. Since 3 times 6 ones is 18 ones, I can't put 18 because I'm only working with my ones place. I'm going to regroup 18 into 1 10 and 8 ones. You can notice in the model the picture where the 10 ones were created another 10. For step 2, I'm going to multiply my 3 times my 3 tens. 3 times 3 tens is 9 tens, and I have to add that 1 10 that I regrouped to give me 10 tens, which in fact would be a total of 100. My answer for 36 times 3 is 108. Let's try again. Now that we know Celia's racehorse runs 108 feet in 60 seconds, let's check with an estimate to see if it makes sense. Our problem was 36 times 3. And if I'm going to estimate, I want to round 36 to the nearest 10. Since it has a 6 in the ones place, 5 or more I raise the score, and 36 rounds to 40. 40 times 3 is 120. 120 is more than 108. But 40 is also more than 36. And 120 and 108 are close together. So I can say that my answer is reasonable. 108 is close to the estimate of 120, and our comparisons were both greater, so my answer is reasonable. Let's try this. Let's multiply 8 times 22 using the regular algorithm. 22 times 8. Just like with partial products, write the bigger number on top. And for step 1, multiply 8 times 2 ones. 8 times 2 is 16. So I'm going to put my 6 ones in the 1 column, and I'm going to regroup that 10 into the tens column. Now I'm going to multiply my 8 times my 2 tens. 8 times 2 tens is 16 tens. I add in my regrouped 10, giving me 17 tens. I fill that in to my tens column, which does spill over to the hundreds place in this case, and gives me an answer of 100 476. So try this. Pause the video now and write down this problem, then replay to check your work. If you're not sure how to do it, follow along and copy down this example into your notes. To estimate 68 times 7, I first write my problem down and round 68. In this case, it's a tens number to the nearest 10 and get 70. 70 times 7, since 7 times 7 is 49, it's 490. For my regular algorithm, step 1 is to multiply my ones. 7 times 8. 7 times 8 is 56. So with 56, I'm going to put my 6 ones in the ones place and regroup my 5 tens into my tens place. My second step is to multiply my tens. 7 times 6 is 42. 42 plus my 5 regrouped tens is 47. And I put that down as well to give me an answer of 476. I can use my estimate to see if my answer is reasonable. 68 is less than 70. And my actual answer is less than my estimate. But they are close together, so my answer of 476 makes sense. Now, we already know that 68 times 7 is 476. Let's look at this same problem with partial products and see how they relate. With partial products, I think of 68 as 60 and 8. And I say 7 times 8, well, that's 56. And 7 times 60, well, that's 42 tens, or 420. And when I add those together, I still get 476. If I look at my partial products, I can see my regrouped 5 from my regular algorithm here in the tens place. And when I add 5 plus 2, I get 7. So my 42 plus my regrouped 5 gives me that 47. This type of problem is called an in and out table. What they're saying is if you start with the top line, or what you put in, you get the bottom line. It's what comes out. If I have 1 carton of eggs, I have 12 eggs. 2 cartons would give me 24 eggs. In this case, I'm going to put a C for carton and an E for eggs. And I'm thinking, if I have a number of carton of eggs, what do I have to do to get how many eggs? In this case, I'm not taking my pattern going across the row. What I'm doing is looking at the pattern from the top to the bottom. That's why we call it in and out. From 1 to 12, I could say adding 12, but 2 plus 12 would not be 24. I could say from 1 to get 12, I need to multiply by 12. And in this case, 2 times 12 is 24. So my pattern is multiply by 12. We often call this pattern the rule. So the rule for this table would be to multiply by 12. To write it as an equation, I could say the number of cartons times 12 is going to give me the number of eggs. What are the 2 missing numbers? Try to figure them out, write it down, and replay to check your work. Did you find that 3 times 12 is 36? And 5 times 12 is 60? Good job. Now here's a few problems. I want you to try these on your own and copy down your answers. You're going to submit these answers online in Canvas, and we will review these problems tomorrow in class. Make sure you find the estimate and the exact answer for both problems. Remember to try to use the regular algorithm. You can rewatch the problems that were solved in this video for additional help if you need it to recall the steps in the algorithm. And we will also review this in class tomorrow. Thank you and have a good night.